Welcome to another edition of Math Snacks with Miss Lovely and Miss Wonderful. Today we're going to be talking about the equal sign.
What are we going to be talking about the equal sign?
Well, I want to give us a problem to look at that I saw in a book.
Okay.
What do you think goes in that box, Miss Lovely?
It must be 12 because 8 plus 4 equals 12.
You know, I'm not sure I agree with you.
What do you think it is?
I think it's 17.
How are you getting
8 plus 4
okay.
plus 5. You got to do something with the 5.
Oh, okay. Well, I don't know. That seems kind of odd, but maybe.
So what? Tell me again why you think it's 12.
Well, because whenever we see the equal sign, it means to answer the problem. So 8 plus 4 equals 12.
Okay. You know what? I bet we're not the only one that has some misconceptions there.
Really?
There was actually a study done by a man named Thomas Carpenter,
Really?
along with some of his colleagues, and he put together this book called Thinking Mathematically, and it's how to integrate arithmetic into algebra.
Okay.
And he took this exact same problem, and he took it and he went all around to different classrooms.
Okay, and what did he find out?
Well, he found out kids have the same misconceptions we do.
Oh.
He looked in grades 1 and 2, 3 and 4, and he even checked in grades 5 and 6.
Okay.
And you want to see his results?
Sure.
In first and second grade, when he asked first and second graders this,
I bet they didn't do much better than we did.
58%. That's pretty good, I thought, for first and second
not
grade.
Not too bad. 58% knew it was...
They thought it was 12.
Oh, okay.
58% thought the answer was 12, just like you did.
That's still pretty good.
You want to write 12 in there so we'll remember that's what we're talking
Okay.
about. They think that that answer was 12.
Okay.
58%. Then they went to third and fourth graders, and 49% thought it was 12.
They were getting a little better.
A little bit better. Of course, some of them thought it was 17, like me, too.
Okay.
But,
okay.
And then grades 5 and 6.
I bet they're getting better, even yet. They should be, at least.
Yeah, I thought so, too. But look at those results.
76% thought it was 12.
3 out of 4 thought it was 12.
Wow.
So where do you think some of those misconceptions might come from? Because
I'm guessing it's because we're so used to the equal sign meaning to answer the problem.
Right. Look at some of the things we see in textbooks.
Well, there you have it. 245 times 7 equals, and I need an answer.
Or if I'm doing 8 times 4 equals an answer. So many of our textbooks they're giving a computation problem, and then they get the misconception or they get the understanding that equal means give me an answer.
Give me an answer.
And they don't understand that the equal sign really means the same as.
Okay, so if we're looking at that original problem, 8 plus 4 is the same as something plus 5. Oh, it's leading towards algebra, isn't it?
It is.
Towards that balance.
Okay. So let's see, what does that look like?
Okay, you do one side and I'll do the other. I'll do the first side.
Okay. Well, we're figuring out the box because 12's not correct.
Right.
And I don't think 17 is either.
I don't either.
Okay. So if this is something 5.
There's my 8.
There's your 8.
And I need 4 more. There's my 4.
Okay. I'm going to move them
And that
up.
is 12, by the way.
Yeah. 8 plus 4 is 12. So if it's supposed to mean the same as your 12, and I only have 5 over here, I must need to add 1. I'll do it like you did.
Okay.
2, 3, 4, 5, 6, 7.
So that they look exactly alike. So this should have been a 7.
That should have been a 7. So I'm going to rewrite that for us.
Okay.
Because this is not thinking good.
Okay.
But 8 plus 4 equaled,
or is the same as.
or as the same as, good using that terminology. Remind me to use that. 7 plus 5.
Hey, I'm starting to see a pattern here, but let's keep going.
Okay, so if equal means the same as, what Thomas Carpenter and his group of researchers did was he started saying, well, how do we get kids to be thinking about it as the same as?
Okay.
So he started with what's called true-false number sentences.
Okay.
And in true-false number sentences, it just means he takes students through and says, are these true or are these false questions?
Can I see some?
You sure can. So we'll start with, is 7 plus 3 equal to 10? True or false?
That is true. 7
Okay.
plus 3 is the same as 10.
Okay. How about 10 is equal to 7 plus 3?
Well, I happen to know that's true because we can flip the number sentence either direction, but I bet that causes some problems for kids.
It does. In fact, most of them say, no, it's false because it's written wrong.
Okay.
So if we keep putting that terminology in, 10 is the same as 7 plus 3, we could model that.
Uh-huh.
How about this next one? It's another way to kind of scaffold it for students.
That would be correct as well. True.
Okay, this is true.
Uh-huh.
And so you'll kind of see a progression here. Is 7 plus 3 the same as 7 plus 3?
Yes, it is.
Okay. Is 7 plus 3 the same as 3 plus 7?
I know that's true because of the commutative property, but I bet that one might cause some problems as well because it's written wrong.
Because they're turned around, aren't they? And then after students start understanding that and using the unifix prove that these are true, because we could put 7 plus 3 and 3 plus 7 and prove that they're both 10, then all of a sudden we can start throwing in other numbers so they can start getting different numbers in here.
To find the same values. And you could still use your manipulative that way.
You sure could. And here we're starting to get into the
Zero property.
zero property.
Right.
So is
Cool.
10 equal to 10? So after kids have a good understanding of true-false number sentences, then they take them into what they call open number sentences.
All right.
And they're very similar, but now instead of answering true and false on them, they're going to ask them to fill in the box.
Okay.
So as you look through this list, let me move some of the stuff over. What do you notice about the progression?
It's identical to the last one with the true-false statements. And we just continue to build on the skill. 7 plus 3, we are providing an answer here, but now it's turned the wrong way. So now we're supplying an add-in.
So that's the symmetric property, right?
And then here, 10 is going to equal 10 because there's nothing that we're adding to that. And here it's going to be identical, so it's 7 plus 3 equals 7 plus 3, or is the same as 7 plus 3. So it looks identical to your true-false statements, it's just that now they're supplying a value instead of the answer true or false.
So there's a progression, and it's amazing if you take this in and, you know, in every classroom we start hearing some of the same things, especially when they see this first one. They'll say it's wrong, so then you kind of have to scaffold back. Is kind of what we're doing, is getting them to understand, because that actually comes down here, down to the bottom, the same as the one up top. So it's a scaffolding process, and it has to be done many, many times with students over and over.
Okay.
But that's called open number sentences. But now let's lead up to higher level.
Okay, can we start with this one when we lead up to the higher level?
Can we start with that one? Okay, what do you mean by that?
Well, when I saw this, when we did this with the manipulative a minute ago, I saw a relationship between the two sides of the equal sign. The fact that 8 is 1 more than 7, so the 4 had to be 1 less than the 5. So there's a relationship between those numbers.
Okay.
For it to be the same as.
So you're seeing the relationship between these numbers being 1 less. So this had to be 1 less than this.
Right.
Or this number had to be 1 more than that.
Exactly. For these two sides to be equal or the same.
Okay. When we give students small numbers like this, even though that's really where we want them to get to see the relationship.
They're still adding, aren't they?
They are. They still want to do 8 plus 4 is 12, and then come over here and say
figure out
what goes in there to make 12.
that 12, right.
Okay. So there's a solution, even with little small kids, that you can do to help them start seeing the relationship.
And I want to see what it is.
You got to throw in big numbers. Okay. Numbers that you say, you don't really expect me to ask you to add the size of a number. Right. We haven't, you know, this might be a first or second grader, and it's like, well, you know we haven't worked with adding that kind of numbers.
To the thousands place.
So if we use that same theory here, that this number was 1 more than this number, and this one had to be then 1 less than this number.
Right. We're going to do the same thing here.
Okay.
Because 5,328 is 1 less than 5,329. So the number that we're going to put in this blank is going to have to be 1 more than 52. Or 1 less. 1 less, sorry.
Than 52,
I went the wrong direction.
So it must be 51. See, that gets confusing in itself,
You
doesn't
do have
it?
to think about it. You do have to think about it.
So let's try another one.
Okay.
And look at a relationship between numbers. So we can't do this whole adding things. 2,428
Trying to stump me again, aren't you?
plus, and you might look at this for older grade levels. We don't always have to put a box there.
There you go.
Is equal to 2,430 plus 41.
Okay. So now 2,428 is 2 less than this.
I'm going to write down here, 2 less. So if they're going to add up.
So if these two sides are going to be the same, this one is going to have to be 2 more than 41, which would be 43.
So F
Must equal 43.
would be the same as 43.
Hey, I got it right that time.
Wow, cool. Good job, Miss Glovely. So this whole thing with the equal sign is really important, that we really start using that terminology so kids see that equal means the same as.
That will certainly make it easier when they get to algebra and have to keep both sides of an equation balanced.
Awesome.
I like it.
Okay, well, thank you for joining us in another episode of Math Snacks with Miss Glovely and Miss Wonderful. Join us again.